Okay, if we look at this one, both our limits are going to be okay here. 0 if we put it in works, 3 if we put it in works, but we know there is a number here that's not in the domain. If x equals 1, that doesn't work because x equals 1 is not in the domain of this function. We're going to have an asymptote or something going on there. So what you have to do on these types then is because 1 is in between 0 and 3, we're going to split this up. So what we're going to say is we're going to be doing a limit here from 0 to 1 of this function. Plus, if we continue now from 1 to 3 of the same function, these should be equivalent to each other. Now, whoop, I don't need that dx. So now that we've done that, now it looks like those problems that we were just doing. The limit value, that doesn't work on this first one. We'll use t again as we approach 1, so we're going to replace 1 with t here, so because that's our not good one. And if we were traveling from 1 to 0 there, that would be, or from 0 to 1, that'd be approaching 1 from the negative side of this function. Plus, now we're doing another limit over here as t approaches 1. So on this side, we're approaching the bottom limit because that's where 1 is. And on this one, if you're traveling from 3 to 1, that would be coming from the positive side. So now we want to evaluate these and find these antiderivatives. This would be if you kind of think of a substitution, if you want to do a substitution, if we do u equals to x minus 1, derivative would be dx. That's going to make this 1 over u, which we know antiderivative is going to be natural log, and then sub back in. And so the antiderivative here is going to be natural log of x minus 1. And then we want to evaluate that at t and 0. Same with this one's also going to be natural log of x minus 1, evaluated at 3 and t. So now what we want to do is put in both values here and see what we get. So on this one, we're going to end up with natural log of t minus 1 minus natural log of 0 minus 1. And that's why the absolute value is important there, because we can still evaluate that natural log. That would be -1, absolute value makes it +1. And we can do natural log of 1, that's 0. On our other side, if we put that in, that's going to be natural. If we put 1 from the left there, that's 1 minus 1 is 0. So what are we going to get as we do natural log of 0 approaching from the left there? Well, that one we know from looking at the graph of natural log before that this is approaching -infinity, and so here we get -infinity. So we don't even need to evaluate that other one, because right now we know that this side is not going to be convergent. This is a divergent one. So as soon as you see that part of it, even though we didn't really do this limit, this one's going to come out to be divergent. It's going to be divergent. All right, why don't you pause a video and see if you can do a similar one here. All right, let's see how you did here. The one that's going to make this one bad is 0. 0 is not in the domain, so you want to split this into 2 integrals, one from -2 to 0, because that's our limit there, and the other one from 0 to 3, again with 0 being our limit here. Also, I rewrote this function as x to the -3rd on both of these. Antiderivative them, just add 1 and put the reciprocal. Now when we evaluate this by putting in t and -2, we'll get what we have here. This one we could solve out and figure out that value. This is the other one though. So this is the one we're really kind of focused on here. What's that going to approach as 0 from the negative side? Well, if you put 0 in, we still got the dividing by 0, but from a side, we do have something here. From the left side, you can see this is approaching negative infinity. And so once we know that that's negative infinity, it doesn't really matter what this one or this stuff's going to be equaling, because this one is, again, going to be divergent. This is not, there's not a finite amount of area of this one.